Hello everyone, my name is ITOYANAGI. I'm a climber. In particular, I do a lot of sawanobori. It is said that the best way to enjoy the mountains is sawanobori. So I wade through rapid in the wilderness, climb waterfalls, sometimes procure food locally, sleep by the fire, and head for the headwaters. In this presentation that you are about to see, I'm gonna be a bit adventurous. In Japan, adventure has long been looked down upon. In the book Japanese Adventure and Creative Mountaineering, a young man named Kentaro Kaneko attempted to cross the Pacific Ocean from Japan to the United States on a 6-meter by 4-meter raft made of 39 drum cans and square lumber on February 18th, 1962. The raft had sails, a ladder, a bedroom, and 6 months' worth of food and water. He even studied the buoyancy of the drums and the rate of corrosion by seawater to create a complete ship. To our surprise, it sounded like an incredible adventure, but he was arrested by the Japanese Coast Guard just 30 kilometers away from Japan. Two months later, on May 12, 1962, another young man, Kenichi Horie, left Japan for the United States by yacht. 3 months later, on August 10, 1962, his family filed a missing person report, and the Japan Coast Guard searched for him to rescue him as a suicide. Still, he arrived in San Francisco 2 days later, on August 12, 1962. The Japanese Coast Guard talked about him that he would be deported from the United States and arrested in Japan. And what he did was just a disregard for human life. There was nothing but condemnation on Japanese TV news. Still, the mayor of San Francisco decided to make him an honorary citizen, stating that Columbus also omitted the passport. What he had accomplished was the world's first solo non-stop crossing of the Pacific Ocean. As the American media began to praise him, so did the Japanese media, and the Japanese police never arrested him upon his return. In the book, Japanese Adventure and Creative Mountaineering, which presents this case study, the author says the following. In Japan, adventure is supported only when it is not reckless. But adventure without recklessness is an objective contradiction because adventure is inherently reckless. The surest way to avoid failure is to do nothing. If you are even slightly adventurous, stop. This is the basic philosophy in Japanese society, where creative work is currently scarce. My backpack is too heavy. Adventure is unacceptable in Japan. You must show only your success in Japan. You can't show that you are trying in Japan. This is because try includes the one thing that Japanese society hates the most, failure. So, this video is a secret in Japan, okay? I'm showing this video to you because the place to publish is in America. Finally, I arrived. I'll just be back today here. This is my house. Yeah. The Japanese people have lived with the rice cultivation for thousands of years. The many small countries that existed in medieval Japan even showed their size by the amount of rice they stockpiled. Rice is our soul. No matter what the situation, we eat rice. And this is, for example, what is called hagama in Japanese, which is used to hold the rice in frames for the best cooking. And so here is a hole of the same size as it. But so small. Oh, uh, no, no problem. No problem. Okay, good. Now let's get down to business. Ruby 2.7 provides a new IRB with multi-line editing, syntax highlighting, auto-indentation, compilation, and document view. However, this caused a significant slowdown when working with long line of code, especially when pasting long line of code. There are many reasons for the slowdown. One of them is that we had to rewrite the screen every time we wanted to display text. So sweet. Matcha. Skim milk. It's means is a kind of sugar. Matcha latte. Morning. Okay. There are many reasons for the slowdown. One of them is that we had to rewrite the screen every time IRB wanted to display text. Since the pasted strings were processed one character at a time instead of all at once, IRB rewrites the screen each time, an essential feature for syntax highlighting, but it was getting slower and slower. There is also the problem of the character width. Some characters in East Asian languages have different display widths depending on the environment or the settings. The East Asian character width specification in Unicode is defined in Unicode Standard Annex number 11. The tens of thousands of characters, including kanji characters, have character width information attached to them. If IRB didn't handle character width correctly, the cursor width appears differently than it is, and the screen will break. And the processing of J's character width was causing massive slowdown. Explanation of East Asian character type are complicated for non-East Asian to understand. So I'll explain them by emoji. Emoji were initially manufacturer-specific feature used in some cell phones, sold only in Japan in the 19th. The word "e" means picture, and the word "moji" means graph in Japanese. In other words, emoji is a Japanese word meaning pictogram. The emoji is not abbreviation for emotion. Just as you have to develop different apps for iPhone and Android, Japanese emoji were not compatible with other manufacturers in Japanese companies. When the various specifications were merged, and the Unicode Consortium decided that this would be adopted into Unicode in 2010. I remember many Japanese programmers assuming it was just joke news. Let me show you some of the scary specifications of emoji. 60 years ago, impressed by the beauty of black telephone designed by Henry Dreyfuss working for AT&T, a Japanese national agency decided to officially adopt the black telephone, and for the next several decades, only black telephones were used in Japan. This one. Several dozen years ago in Japan, this black telephone is so famous. Everyone used it. And I'll show a demonstration. In 1959, a standard called CO59 was established among 6 Japanese newspaper companies to handle images in text. This standard was adopted for a commercial short messaging service in Japan and later ported to cell phones. This is what the beginning of emoji. This is the code table in the short messaging service. Just as you can type a message by pressing the push button on a regular phone, you can type a character by pressing 1 to 9s. This method of communication, which includes prototype of emoji, led to the explosion of a product called Pocket Bell in Japan in the 1980s, which deals only with short messaging services. Here is the emoji character of a black phone. For the Japanese in the past, this beautiful phone was a telephone itself. Another 10 years have passed since then, and the first emoji used in cell phones are in the collection of MoMA in New York. Unicode has information about character widths called East Asian ambiguous. This is a way to change the width of character depending on the terminal settings. This applies to Cyrillic characters, for example. Here is a special case. There are 2 types of emoji, textual fashion and emoji fashion. It's not easy to understand, but the old Japanese monochrome LCD cell phone displays are textual fashion, while the modern colorful ones are emoji fashion. The old Japanese monochrome LCD cell phones could only display half-width characters, and by extending the ASCII table, they could handle Japanese characters with half-width characters. Emoji characters were added and extended by each cell phone carrier according to their specifications. The textual fashion mimics the implementation of the time, so some terminal software will display the same half-width characters as they did back then. However, the emoji fashion is full width. Now, look at the text carefully. The character width changes depending on the variation selector. It's getting outrageous. I'll show you a scarier example, which is not even that uncommon in emoji. There are many more examples of this kind of things. These are 2 emoji characters, I and left speech bubble. This is the emoji fashion character. When you add emoji fashion, the two emoji characters change to be colorful. This is a glue character. If the glue character glues emoji fashion's eye and emoji fashion's left speech bubble, they form a single letter I in speech bubble. What is this? There are 140,000 characters in Unicode, which will be synthesized and further increased. Implementing them correctly will inevitably require complex processing and huge tables, which will slow down the speed. If they are not implemented correctly, the screen will break. But sorry, so battery is so please wait. Okay, this is the generator. I'm waiting for the generator to warm up. Yes. Come on. Yes. This is battery. Yes. 1.3 watt charging. Oh, stopping. Wow. This is perfect social distancing in development. Big three things: food, water, shelter, and power. Generating and charging and developing. Perfect. Chopsticks. So weird. My laptop is just okay. Ruby had to support various platforms, including Linux, macOS, and Windows. And every change I made caused unpredictable bugs. So I developed an end-to-end testing framework that launches a terminal on Linux, macOS, and Windows to run IRB inside. Type some code and check the result displayed. The testing framework is Yamata no Orochi Gen. Yamata no Orochi is a kind of Hydra-like dragon from Japanese mythology. It has 8 heads and was killed by cutting them off. I choose this name because I wanted to kill the bugs that occur separately in Unix-like OSs, macOS, Windows, and other environments. I show example code. First, require Yamata no Orochi, then create a class that infers from Yamata no Orochi test case. Then define test methods, start the software you want to run in the terminal with start terminal method. Write it with write method, finally close the process and test the final screen state with a third screen method. It's easy, right? Especially the right and bottom edges of the screen are flaggable on developers will the test for those areas thoroughly to prevent bugs from recurring. You won't actually see any screen, but I can turn on the screen display in Windows so that you can see how the test is actually running. Please take a look. The Yamata no Orochi gem automatically starts up new terminal, type keys, tests rendered output, and repeats. This will allow you to check that the final behavior is the same, even if the implementation is completely different in each environment. When you have added a large number of tests for a large number of small behaviors, you can finally start speeding up the process. There are two main points of speed up. First, speeding up the Unicode giant table. This has been improved quite significantly by Endo-san. Next, we consolidated the process when testing, reducing the number of screen updates to the lowest possible. I want to go into the details of modification because they're enormous, but I've probably added hundreds of commits just to speed things up. As a result, Ruby 2.0's IRB is 53 times faster than Ruby 2.7's testing process. Okay, and it's time to go to the summit because maybe 4 hours later I have a meeting. This is my house, but I will go from here. I go home now. Sayonara, my house. Hello. This is around 2,600 meters height. It's alpine climbing. See you next year. In-person conference in America. I'll be back alive. Bye.